Okay, so we're continuing section 1.1, looking at systems of linear equations. And let me give you a moment to copy this example down. Okay. Okay, so this is a theoretical exercise to help you understand, to reinforce the concepts. Well, this problem, you see, it's a theoretical problem because you have this variable h here, and they want you to determine the values of h such that this matrix is the augmented matrix of a consistent linear system. Okay, so consistent, and let me just get hold on, my stylus. Consistent means that there is a solution. There is a solution. Okay. So, like, for example, let me go to the whiteboard real quick. Let me go to the whiteboard. Let's say you had an augmented matrix like this. 2, -3, 2, and 1. 0, 1, -4, and 8. And 0, 0, 0, 15. It's an augmented matrix, so we understand it represents a system of equations. Is this system of equations, and this actually relates to example 3 in section 1.1 in your textbook. Is this system of equations consistent? So you think that's a yes or no? All right. Yasin and Jonathan say no. Okay, well, why would that be? Why is that? What's the last equation say? This last equation. So you can see it's in triangular form. Yeah, 0 can't equal 15. I think of the last equation as like this: 0x1 plus 0x2 plus 0x3 equals 15. That's what the last equation, that's how we read it. So does an x1, x2, and x3 exist such that this is true? Could there be variables x1, values of variables x1, x2, and x3 such that 0x1 plus 0x2 plus 0x3 equals 15? That's right, and the answer is no. So this system, it's inconsistent. It's an inconsistent system. So now what we do, well, are there any questions on this? Any questions? Okay. And by the way, you notice in the problem, like in example 3, what they did was they started with a original system of equations, and they did the forward phase of using row operations and ended up with this augmented matrix. And then they don't even do the backward phase. It's no value, right? Because you don't have a solution. But let's now go back to the back to that problem we were looking at. One moment. Okay, so determine the values of H such that the matrix, this matrix, is the augmented matrix of a consistent linear system. Well, okay, let's do that. Here's our solution. I have to reduce the augmented matrix down enough so that I can answer the question. So what I'm going to do, what we're going to do is, it'll be helpful if we had a 0 in this spot where the 3 is. So I'm going to take, I'm going to, using the 1 as a pivot, I know negative 3 times 1 plus 3 equals 0. So that tells me then I should take negative 3 times the first equation, plus add it to the second equation, and put that and replace the, and that'll be the new result for the second equation. And that's going to get me this augmented matrix here. Notice that negative 3 times h plus 6 is 6 minus 3h. So we don't need to do any more row operations. We have enough. We've broken down the system of equations enough to be able to answer the question. The second equation reads 0x1 plus 6 minus 3h times x2 equals negative 4, which means 6 minus 3h, that scalar, times x2 would equal negative 4. What can 6 minus 3h not be equal to? 6 minus 3h, if we're going to have a consistent system, 6 minus 3h could not be equal to, well, you can't have this last equation here. And I heard some good answers here. Actually, hold that thought. So the system is consistent when h is not equal to 2. Why is that? Why is that? Because if h were equal to 2, then the second equation would read out as, well, you put 2 in for h, you're going to get 0 times x2 equals negative 4, and there's no solution to that. There's no solution to that. So h can't equal 2. For any other value of h, you're going to get a non-zero number as a coefficient of x2, and you'll therefore have a consistent system. If you think about it, think of it like this. You can think of it like this. Might be helpful to think of it this way. x2 equals negative 4 divided by 6 minus 3h, right? Based on this equation here, x2 equals negative 4 divided by 6 minus 3h. Well, what can't you have in the denominator? what value is not allowed in the denominator? A 0, that's right. So therefore h can't equal 2. How many like, that's right, Tasmia, how many like thinking about it kind of in this context? Is that helpful to another way of looking at it? Okay, all right, David, very good, very good. Okay. So this is where linear algebra is a little bit different from some of the other courses you've seen. You're going to see some conceptual exercises like this, and you'll even have in the multiple choice, you'll even have some true false questions, right? And so, or some matching type questions. But everything is, but it always helps to, with these conceptual problems, to sort of think concretely. Let's look at another example here. Are there any questions on this one? Okay. Okay, let's look at this one. Let me give you a moment to copy the example down. Oh, great. And while we're at it, let's see. Fatima, can you hear me okay? And not Nell, can you hear me all right? Just give me a thumbs up if you're hearing me okay. Good. So Fatima, did you get into My Math Lab? Did you get in there yet to open up your, did you successfully register so you can access the homework? If you had trouble, can you stay after class a moment so we can, I want to make sure you're able to access that homework. Does that sound good? Just let me know here. Okay, so I assume you're trying to get in. All right, that's fine.
Professor, is the homework's due date is like 26?
Yes, that's right. Two days away. I think you ought to be able to manage that assignment. You're gonna have to leave, maybe 3 hours to do it, right? You're gonna have to leave some time, but that's just it's a 200 level math course, but you'll be fine. You'll be fine, Tesmia. You'll be fine. But yep.
What was the question that she just asked again?
I think she asked, is it due Wednesday, right, Tesmia? The homework?
Yeah, that's what I asked.
It is. It is.
Okay, and then you'll just reopen it at the end of class. So we can
I will reopen it at the end of class. Absolutely.
Okay. Yeah, sorry, I just missed the question because I was solving the matrix.
Yeah, I'm sorry, Mikhail. I guess I kind of interrupted your flow there, didn't I? But it's just because during the lecture, if students are, hey, it's a natural thing, right? You want to finish up the problem, but I don't want you to miss any of the concepts in the lecture either. But do not worry, we'll open that homework up.
Okay.
All right, well, let's take a look here. Now, this is a similar type problem. We're given a augmented matrix. Okay, we're given an augmented matrix here, and we want to determine the values of H such that this augmented matrix is for a consistent linear system. That means there's a solution to the system. So what do you think we would do? What do you think we need to do for this problem in order to solve the mystery? we have a system of equations. Is it easily known what the value of H would be?
But not
Right.
right
Not
away.
not
But
yet, right?
yeah,
I'm
we need to
sorry.
do one operation.
That's right. And Balin agrees. We have to simplify the system with the row operation. That -4, we'd like to have a 0 there. So let's do a row operation and break the system down a little bit. Okay, so 4 times to produce a 0 where the -4 is, I'm going to use that 1 above it as a pivot. 4 times the first row plus the second row. We take that result and replace the second row with that result. Now let me see, there's a question here. Well, Mikhail, you know, we're going to find out. We're going to find out. This gets us down to here. And again, what helps me tremendously is to write out the second equation. So I'm not focused on the first equation. I'm focused on the second equation because that's the equation that has the H in it, right? And I'm trying to study what H could be. So there's the second equation. There it is. And it turns out, Mikhail, you were right. The system is consistent for all H. So let's sort of, you know, concretely see why. Obviously, if you have a 12 plus H in front of the X, if that's the coefficient of X2, there's two interesting cases. One is if H equals -12, and one is if H is not equal to -12. See, I'm trying to get this conceptual idea down to a little more concrete. Well, if H were equal to -12, the second equation would read 0 times x2 equals 0. That means x2 equals 0. That's okay. X2 can equal 0, and I can substitute that back in the first equation and solve for x1. No problem there. On the other hand, if H is not equal to -12, well, remember, x2 would equal 0 divided by 12 plus H, right? And so if H is not equal to -12, then 12 plus H is not 0. So you're taking 0 and you're dividing it by a non-zero number. That's going to get you 0. So no matter what H is, the system's consistent. So therefore, if it's like a multiple choice problem, you would select system is consistent for all H. How many of you think that's kind of a cool problem? Kind of a nice, interesting problem. Okay, Mikhail's liking it. Just Mikhail, I hope maybe there are a few other people. All right, Balin likes it, okay. And all right, Yasin likes it, excellent. Perkurti, wonderful. And I say the names, you know, a lot of times because I want you to know I'm looking at responses and appreciate the participation. You know, these kind of problems, it's very helpful. Like for me, I mean, how many find this like this breakdown here helpful, just to sort of help you feel comfortable with the fact that the system's consistent for all H? How many find that helpful? Okay, Yasin does, wonderful. Marcella, wonderful, wonderful. Yeah, you know, and Mikhail, and David says, let's see, the 12H minus 12. Which part, Mikhail, are you can use your pen. Can you circle the part that you're uncomfortable with? That part. Oh, well, all I'm doing is when h equals -12, what I'm doing, the coefficient in front of x2 is 12 plus h. So I'm just replacing the h here with -12. You see? And that would get me a 0. Then 12 and -12 make 0. This is a plus sign. Yes, this is a plus sign. Okay, good, good. Right, that's right. That's correct. Okay, so we're almost at the end of our class here, but how many of you are finding linear algebra to be, hey, this is kind of interesting class? How many are feeling that? I'm kind of hoping we'll hear a lot of responses. All right, Prakriti and I mean, it's Zishan, wonderful. Mikhail says computer science the 207 class. Yeah, it's fun. Edward says it is different from calculus. Yes. Marcella and Jonathan are liking it, and David. Yes, David's a little. Don't be scared, David, because I'm going to be with you, helping. I'm going to be helping you all. I want to help you all be successful in this class. And Cameron, but of course, to be successful, everyone has to do their homework, right? Very important. I agree, Tesmia. It's different from calculus, but and actually, Bella mentioned differential equations, Math 282. You know, differential equations, you're gonna remember you had if you've taken it, remember you had eigenvalues and eigenvectors to solve systems of linear equations. You're gonna understand in this course why that method works. You're gonna understand it, why that method works. So a lot of beautiful applications in here. On that note, all right, I'll stop the recording if we're good. Any other questions?